Let's proceed. All right, here we go. These next two problems are similar to the previous two problems in that they might look the same in their structure, but their approach is going to be different. And their approach is different, and here's why. This one has a u that is the denominator, and this one has a u that's, well, we'll talk about it when we get there, okay? First of all, let's talk about what I just said. The u is the denominator. Most of the time, and this is not always the case, but most of the time, u is the denominator. For just a second, we're going to pretend like we don't know that. Just in case you're wondering, like, how do you know? How do you know it's the right thing? Let's pretend like we don't know, and we're going to say that u is just x. If you're like, what's the inner function? Oh, let's pick the numerator. All right, we'll try it. Then I have du, which would equal to 1 dx. It's getting serious. The glasses are coming off, perched on the top of my head. And therefore, as we proceed with this, don't write it because it's wrong. As we proceed with this, we'd say, oh, well, u is x, so there's u. Dx is du, and then the denominator was x squared plus 4, so u squared plus 4. The purpose of u substitution is to make things less complicated, and that's not. So, yeah, that got us nowhere. So, again, not always, but most of the time, u is the most complicated, or u is generally the most complicated part. Often that is the denominator. So u is x squared plus 4. Du is 2x dx. And I don't want 2x dx. I want 1x dx. So as we begin to identify the specific parts, before I go any further, let's just go ahead and set this up. The biggest thing happening is that there is a fraction with u in the denominator. So there's u. What was the color on that one in the last one? I think it was green. So I think my u was green, so there we go. Those are taken care of. And now we're going to have to take care of x dx. So I need this to say x dx, not 2x dx. So we'll fix it to where it says what it needs to say. So x dx, fantastic. We'll divide by 2. We'll call it 1/2 du in this case. So we're going to have 1/2 du. So over here on this side, we'll have 1/2 du. Not the only way to write that. And so if you're looking at this and you're thinking, hey, I'm just going to bring that u up and let it be u to the -1. That's cool. You're not wrong. But I want to point your attention to, draw your attention to something just for the sake of making it a little easier to look at. There used to be a whole lesson devoted to this, but I don't find it necessary anymore because we have all kinds of amazing things, like a page full of integral rules. Notice that top one right there. What you see on the paper and what you see right there on the board are two of pretty much same thing. So if I am dividing by something that has a denominator to the first power, collectively the denominator is to the first power, then I can use natural log in the integration. So that denominator is to the first power, so it's really natural log of absolute value of u. You can't take the log of a negative number or of 0. Well, and you can't divide by 0 anyway. You can't take the log of a negative number unless you're wanting to play with imaginary numbers, which you know how I feel about imaginary numbers if you know me. They do exist, and I am intentional in this. I'm wrong. I've left something off. What did I forget? 1/2. Okay. So if I want to finish this thing, and I do, I'm going to take x squared plus 4 and I'm going to plug it in right there. Let's pause for a second. I'm thinking of the absolute value. Absolute value makes things positive, but I'm going to put x squared plus 4 where that absolute value is. So x squared, or in the absolute value, x squared is a positive number, unless it's 0. And then adding 4 definitely makes it positive. So I don't even need the absolute value bars anymore. You can keep them if you want to, but it's not necessary. And let's put a C. All right, so as you look towards the next problem, and I'm standing in the way and you can't see it, but as you look towards the next problem, you'll realize that if I let u be x squared plus 4, then I would have the same situation I did on the last pair of problems, where du involves an x, but I don't have another x floating around. And I can manipulate things by multiplying or dividing by a constant, but I can't just make up another variable and slap another x in there. There are ways around it, but not with this structure. It's just not going to work. So we are going to have to go about this a different way. And thinking back to what we did on the previous pair of problems, that in the previous pair of problems, the first of those the second problem was arc sine. This one's arc tan. Watch. The derivative of arc tan is 1 over 1 plus x squared. It is. It is. Are these the same? Somewhat, yes. Okay, I'm going to go about this one the same way we did the previous problem, but then I also want to do this one the way it's listed on a formula sheet that you have, the same formula sheet I have been pointing at. So here we go. I want this to look like this. Well, first of all, the denominator is out of order. That is not a huge deal, but just to be consistent with the structure, I'm going to do that. I'm going to fix it. So let's see. I'm going to have the integral of dx over 4 plus x squared. That is probably a waste of a good step. You wasted your pencil lead or your ink, but there we go. That's it, just because, yeah. But I want this to be a 1, so we're going to turn this into a 1. So same idea on the last problem. We're going to factor out a 4, and we're going to have 1 plus x squared over 4. And then just kind of looking ahead that I really want something to be squared, and that something is squared, but then it's divided by 4. Let's make it all collectively one thing. So we're going to have 1/4. We'll factor the 1/4 out. And we'll have dx over 1 plus x over 2, and it is squared. Okay, so now we're ready to go with this idea. And as I do, we're going to identify what u is. And u is x over 2, which means du is 1/2 dx. I don't want 1/2 dx. I want 1/4 dx. And so I'm going to get my 1/4 dx by dividing by 2. So I want 1/2 du. All right. Let's do this. Things get fun here. So we're going to have, let's see, the integral of, and then let's see, what's the biggest thing happening here? Well, a lot of things are happening. This is what's happening here. This is going to be 1 over 1 plus u. That's really, this is the structure of what we're dealing with. So 1 over 1 plus u, and it is squared. Okay? So if you're kind of keeping track of what's what and what needs to be underlined with what color or highlighted or whatever, that is u. But what we haven't dealt with is this 1/4 dx. So we're going to have 1/4 dx. And so I need 1/4 dx over here, but it needs to not say 1/4 dx. It needs to say 1/2 du. So we're going to have 1/2, we'll put the du in the numerator. Okay? All right. Well, let's take an antiderivative. The antiderivative of this, and you might be tempted to say, well, why don't we do the same thing we did here with a natural log and the stuff in the denominator? No. This, other than the 1/2, this is this. Because if you wanted to, just to make it look even more like it, you could put this du over here. There we go. So this is this. So the antiderivative is, there's a 1/2 floating around. Let's not forget him. 1/2 of, okay, well, antiderivative of this goes back to arctan. So it's arctan of u, and then plus c. That's an ugly c, but whatever. A lot of pollution in that C. Ha 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 ha. All right, we're going to take u, which we decided was x over 2, and we're going to put it back in there. So we have 1/2 arctan of x over 2, and then plus c. Okay, that was a lot of work for this problem and the similar problem that is above it, if you're following along in the paper. There's a lot of work, and so there are a couple formulas. I pointed it out at the end of the last video, so I'm going to actually work this entire problem again. You're like, no, make it stop now. No, hang with me, for real, trust me on this. So there's a formula we're going to use, and we're going to do this entire problem again much faster. So then the question is, why'd you do it this way? I want you to see how these things can be manipulated to get where you're going. Because if you forget the formula and somehow you have time on an exam or you just are enjoying the mathematics, which I hope you are, then you'll be able to identify and work through this and get the correct answer. So here's a formula, I'm going to erase this top one, that is on your list of integrals that you need to have memorized. And it is, you need to have memorized, and then I picked it up, right? Okay, I got this. The integral of du over a squared plus u squared equals 1 over a arctan of u over a, and then of course plus c. Okay, this is the reverse of that, only we're kind of undoing the chain rule with u substitution. And similarly, this is what I pointed out on the previous one. See, told you that's what it was. Here's the other one that we had done on a previous problem in a previous video. There it is. We could have done it this way. Now I'm going to do it this way. And here we go. I'm going to look at this, and I'm going to work it out down here in red just by identifying parts. So I'm looking at this saying that looks a lot like this, so we're going to just kind of go with it. So let's figure out what's what. Okay, well, u is a function which involves an x in this context. So u squared is x squared. So if u squared is x squared, then u is x. Okay, fantastic. Let's keep driving this bus. So du is 1 dx. Okay, let's keep identifying things. A is a constant. A squared is 4. A lot of this can happen in your head, but it's the first time we've worked it out like this. So a is 2. Let's not do the plus or minus thing, just don't. So a is 2. Therefore, we actually have everything we need right now. We're ready to go. I am taking this, putting it into this format. This next thing that I'm going to write might look a little ridiculous because I'm kind of rewriting this whole thing right here, but then it's just going to get cranked out to look like that. So what I have is the integral of, well, dx is du, x squared is u squared, 4 is 2 squared, so that's a squared. I'm going to call it 2 squared. And that is equal to, oh goodness, yeah, let's leave it as an a. Let's leave it as an a squared. So what I'm writing here is basically what I have here, and it's going to be 1 over a, I'm writing the formula again. Never hurts to copy a formula again, just so you'll remember it. So now I'm ready to basically just plug the a in, plug the u in, be done. So final answer is 1 over a, 1 over 2, arctan of u over a, which would be x over 2, and then plus c. Same thing we had over there, only I left the parentheses off this time. Not that it's a huge deal in this situation. There we go. So if you have this formula memorized and you can identify the parts, you got what you need.